Assalamu alaikum. Welcome to this MATLAB tutorial. In this tutorial, I am going to teach you how to design PID controller in PID tuner using MATLAB Simulink software. Friends, in the power system, we commonly use the PID controllers to bring the frequency, voltage and other parameters to their original value. However, tuning of the PID controller is very difficult. Most of the times, hit and trial method is used, which is extremely time consuming. Furthermore, despite of so much time, it still failed to provide the best response. But now, no need to worry about the PID tuning of any system. MATLAB software in its latest versions has provided the PID tuner. In this PID tuner, you just have to put the response of any model from the Simulink and it will automatically provide the tuned response within fractions of seconds. Let's learn how this PID tuner can successfully tune the PID controller and provide the best response. For this purpose, I have considered the voltage graph of the model, namely how to design automatic voltage regulator model of thermal power plant using transfer functions in MATLAB Simulink software. The basic designing of the model may be found by watching my video on this topic, which is already available on my YouTube channel. Therefore, at this moment, I just open the AVR model here to save the time. Now to get better visibility, I am going to do some other changes. First, just put your mouse cursor anywhere in the Simulink model and start writing dashboard and press enter. You will see a blank window will appear. Bring this blank window here. This window is basically a scope which will show directly the graph without opening the scope. Just double click on this window, a new box will open. Now click on this line which is connected with a scope. It may be noticed that now this scope name is appeared here. Just select it in order to see the graph and press OK. Now double click on the PID controller. It may be seen that the parameters of P, I and D for our model are 1, 0.25 and 0.28 respectively. At these values, the satisfactory response of the PID controller was obtained in the previous video. To show it again, just run the simulation. It may be noticed that this time the voltage graph is directly visible here without opening the scope. In the previous video, we discussed that it was satisfactory response, which was obtained after several attempts. However, if you notice the graph, it still contains large overshoot and very long settling time. Therefore, we are now going to use the PID tuner to tune it properly in order to have zero overshoot and smaller settling time. For this purpose, just double click on the PID controller block. Now just click on this tune button. It may be noted that when you click on this tune button, the MATLAB automatically opens the PID tuner and sends this graph directly to the PID tuner and automatically design a tuned controller response of the voltage graph. You can see the PID tuner has brought the original block response in the PID tuner. Furthermore, at the same time, it has automatically tuned the voltage response with minimum overshoot and smaller settling time. The values of P, I and D for this tuned response are also shown here. Now just click here on Show Parameters to see the different parameter values. It may be noticed that here different parameters of both block and tuned response are shown in order to compare their performance. From this comparison, it may be noticed that tuned response has very similar settling time as well as similar overshoot compared to the voltage original response. Furthermore, it may also be noticed that both systems are stable. However, it may be noted that even though both systems are stable, but the performance of the tuned controller is much better. Now we have two choices. If you are satisfied with this tuned response, then you may send the parameter of the PID controller to the Simulink model in order to get this tuned response. However, if you are still not happy and want to improve its response further, then PID controller has provided the flexibility to tune it further. If you look at the tuned response, you will notice that the tuned response still contains some overshoot as well as higher peak value. Therefore, for further fine-tuning, the PID tuner has given two sliders. The top slider is used to make the system response faster or slower by dragging this button, whereas the bottom slider is used to make system more robust and stable. In order to bring this overshoot further down, just drag this slider towards robust. You may notice that with this slider movement, the voltage overshoot gradually reduces and comes closer to the unity. Continue to drag this slider until you are satisfied with it. Now click on Show Parameters to compare the system performance. It may be noticed that overshoot is reduced to 0.0154% and system voltage peak has reached to 1 per unit. Now if I want to make it more faster, then again drag this slider. You may see now settling time is reduced, but overshoot is again increased a little bit. Therefore, at this point we have to select one choice, whether fast response or smaller settling time. It is because faster response will give rise to overshoot in it, whereas removing the overshoot will increase the settling time and make the controller little bit slow. Now question may arise that in practice which system is preferred? The answer to this question is that in real practice, faster response with smaller overshoot is preferred and acceptable as compared to the slower response with zero overshoot. It is because in control system, most of the time faster response is more important. Therefore, now it depends upon your choice, what you prefer. To further clarify this concept, just consider the following example. Suppose for a control system, it is required to stabilize its response with a settling time of 4 seconds. Now suppose you tune the response, you found that control system stabilizes within 2 seconds but it has some overshoot. It means that you have the choice that your settling time limit is 4 seconds. Therefore, now it is better to increase the settling time from 2 seconds to higher value but bring back the controller overshoot to 0. Suppose at the settling time of 3.5 seconds, your controller has 0 overshoot. It means that now you have obtained the best response within mentioned settling time and with 0 overshoot. However, in some cases we do not have such choice. Then it depends upon you that among both faster response and 0 overshoot which parameter you prefer. Here in this video tutorial I am preferring the 0 overshoot. Now let's start again to get the response with 0 overshoot. At this stage, suppose if you want to see again the initial graph, just click on this reset design block. It will show you the original block and the tuned response. Now you can again try it for the better results. Furthermore, PID tuner provides the facility you can also observe various different characteristics of the graph. For this purpose, just right click on it and click on characteristics and click on peak response. It will highlight the peak response by drawing the dotted line. Similarly, you can see the settling time, rise time and steady state time. Suppose now you are satisfied, just click on this update block to send the updated parameters of PID controller to Simulink block. To check it, just double click on the PID controller block. You can see now the parameters of PID controllers are automatically updated. Now run the simulation again to see the tuned response. You can see now the voltage response has improved and have 0 overshoot and similar settling time than the previous graph. Friends, at this stage I want to highlight another important point. In the Simulink model, the simulation data inspector has another good feature that you can compare the previous response with the new response. To do this, just click on this simulation data inspector. A new window will open. You can see here it saves the response for every simulation run. To make it visible, just select this generator. It will show you the latest response. Now to see the previous graph, click on the above run and select the generator. Now it will show you the both previous as well as the latest graph in order to compare their response. Just click on this color to change the color of your choice and then click on set button. You can see the color of the graph is changed. For better comparison, just click on this data cursor and select on one cursor. Now you can compare the response of both the voltage graphs in terms of their overshoot and settling time. Friends, at this stage we have successfully tuned the PID controller with zero overshoot and similar settling time for the AVR model of the power system. By following the procedure given in this video, you can automatically tune the PID controller parameters for any system. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.